Okay, so the log for the filament transformer, so instead of using the filament winding from the main power transformer, so it was connected there to the first power tube's filament pins, which are the innermost two pins right there, and then is jumper to the rest of the tubes. And by removing that, I allow the power transformer to save up quite a bit of magnetic potential for the core for the high voltage. So right now, the only thing that the power supply will be supplying is the filament voltage for the rectifier and the high voltage. So these two are powered by the mains transformer. So when I use the power switch, which is right here at the bottom of the amp, then with that I will be switching this main transformer, and that will be switching on the rectifier plus the high voltage. And I will use the filament transformer, so I will mount it right here, and it will be connected to the IEC inlet, and it will be permanently on. So once you connect it to the wall, your tubes light up and the filaments glow. And let's see how I'm going to use it. So in the original design, I had the tube socket and I have the filament pins number 1 and number 5, and the two leads of the transformer, the filaments, are connected to these two legs, and they are also connected to a resistor each, and these resistors connect to let's see if we can see it here. Yes, we can see. Can you see that? I cannot. So those are the resistors, those Allen Bradleys, and they connect to the tube socket. And the tube socket is grounded, so this is where the filament is referenced to the chassis. And in the original design, it went, I think each of them are 10 ohm resistors. And now this triad filament transformer, it's the F18X. It's a 6.3 volts, and it has a 6 ampere output. And the total for all my power tubes, I will need 2.4 amperes. So this is more than twice that is needed. And you want to do that because if you oversize your transformer for your need, then the radiated electromagnetic field will be much smaller. So if you run your transformer to the peak, close to the peak current, then the transformer's laminations are getting saturated, so it cannot keep the electricity confined within the coil, and it will start to radiate the EM. So that's when your amp will get noisy and will start to hum, because the EM field just radiates everywhere. So of course I also added this copper shroud to the filament transformer. Here I didn't use extra glass tape underneath because I do not need such high voltage insulation. So in this case the voltage insulation needs to be just 120 volts, which is piece of cake. But for the choke in the filter duty between the C1 that's getting bombarded by up to 650 volts choppy DC, the voltages within this inductor, because it's charging up and shuttling between C1 and C2, it can see up to 1.5 kilovolt within it. So for this it's mandatory to provide something extra between this and your bobbin, because otherwise there's a chance that the voltage can flash through and it will just short your iron.